Hello, welcome back. We will continue to introduce advanced SQL. Now let's look at section 5.9, solving queries using multiple statements. Sometimes you have to write multiple statements in order to solve one query. For example, this example 5.15, find the students who take all the courses taught by Professor George Franklin. This problem can be divided into the following subproblems. Find all the course ID for the courses taught by George Franklin and save the result into a temporary table, temp1. So this is the temp1. We get all the courses and taught by George Franklin. This is all the course ID. Next, we're going to store all the students and course ID into table temp2 for students who take courses in temp1. So this is temp2. We get the students who take the courses in temp1. And now we're going to display students in temp2 whose count is the same as the count in temp1. So you get the students and from temp2 and whose count, this is the same as the count in temp1. And drop all the temporary tables. So what we need is to get the students who take all the courses taught by Professor George Franklin. So this will be all this. So again, let's review it. And we're going to find all the courses taught by George Franklin. So this is in temp1. And the next, we get to temp2, and we get all the students who take the courses in temp2. And then we're going to group the student, and here in this this from student from the temp2, and who have this same count as temp1. So then we get the students who take all the courses from Professor George Franklin. So you don't have to just write one very long query. You can break it into several steps. And this is something you may do when you encounter some problems, and you can think it in your way and in your intuitive way to get a solution. All right, so now let's look at the new concept of views. We can create tables. Now, what is a view? View is this. We look at the concept of external views when we introduce the database system in chapter 1. So view is like a window to the database. It's a definition. It does not actually store data. It's a mirror of the data. It's just a view. A view is defined based on one or more tables or even other views. So here's the syntax to create a view. Create or replace a view. And here is the view. And you're going to use the select statement, and to get to this is view name, and this is the optional column list for the view. So and here you have the check option and with read only. So what are these options? So this is obviously create or replace. You can create a new one. If it already exists, you can replace it in the same view. And this false option creates a view even if the underlying table does not exist, you still can create it. So that's the false. In this case, the view is created but cannot be used because the underlying table does not exist. The view can be used once the table is created. The default is no false. The column list specifies the column names in the view. The number of columns in the list must match the number of columns selected from the select statement. With the with check option clause specified, database system checks whether the condition specified in the where clause of the select statement is violated for every. So here is the check option. So whenever you perform operations through the view, insert, delete, and do all this, see if there's a constraint, you need to check if it's satisfied. If not, it's going to raise an error. So with read only, clause specified the view is not updatable. You cannot see, basically you can use view just like a table, but it's virtual. It's like a window through the view. You can actually access data, modify data, but you can put this with read only. So this, you cannot modify data through the view. For example, now we're going to create a view, create or replace a view. It's a faculty course. So this is the name of the faculty in the course. So we get the faculty name and the course title. And from this faculty taught by course, and where this faculty social security number is taught by social security number and taught by social security number. Course ID is the course ID with read only. So here's another example. Get the CS faculty and the social security number, the name, and the department ID. So now you're going to select this and get only CS. So this is the view for CS faculty. The view has the with check option specified. So here, with check option specified, if you attempt to insert a row using the following statement, so here's the statement right here, the database management system is going to reject it because here you cannot have any math. In fact, because this says it's a CS, you cannot have any math faculty inserted through this view. A view cannot be updated if it contains derived columns. So here, for example, you have this is social security number, name, department. All right, but when you select it, you have the name is this is derived. It's not real in the database, so you cannot update it. And no insertion if its base table contains a column with the not null constraint. No insertion if the select statement in view definition has an order by. No. No insertion if a view is defined on multiple tables. Update and delete operations can be performed on a view that is defined on multiple tables, provided that the table has a primary key and other restrictions are not violated. So to drop a view, so you just use drop view to delete the entire view. You can also alter the view using alter view command, and often it's more convenient to just use create or replace, so you don't have to mess up with auto. All right, so you can now solve queries using views instead of creating the temporary tables, and then you have to drop it later. So it's better, it's actually more efficient this way to create a view. So for example, you can rewrite the previous example. We created the temp tables, and now instead of creating tables, we create a view. So we get find all the students who take all the courses taught by George Franklin. So that's what we have there. All right, so using views. Okay. All right, this is kind of Oracle specific. There's a row ID and row num, and so just and read it. And after this video, and the indexes. Indexes are optional structures associated with table. Indexes can be used to improve database performance. You can create index on one or more columns of a table to speed SQL statement execution. Now, this one here, so please read it and just get to know what is this creating index. So normally we don't do much of this in practice now. But it's good to know it's internal data structure here, and we can manipulate it. All right, and clusters. And so this is some advanced features here. In the Oracle database, and the tables are related through common columns. And often common columns are used to join tables to speed up the join operations of the table. On common columns, you can create clusters to group these tables together. So this is something to do with the internal database, to do with the database implementation. Okay. All right, so this is good to know. And so this database links and distributed queries. So, and so please read this. It's advanced features. We don't use this very often. Synonymous, and this is something and also useful, but it's mostly in the Oracle database now. You don't find it in the SQL database. So I'm going to skip it, and the same thing as sequences. All right. See, Oracle database is really the mother of database. It has a lot of features, and it allows you to get down into the physical implementation level of the database system. So please just read and to know it. And most important thing is you go to the review questions now, and all this things. So just get to know, hey, what is a cluster, and what is synonym, and so what is the database link. So read and from the text, and just get to know it. And so review questions, and this is the exercises. And so that is all for this chapter on advanced SQL. Thank you very much. See you on next video. Goodbye.